All right, section 4.5, we get into what sampling distributions are and how they differ from a population. So the essential question is, how do I compare a parameter to a statistic and explain how a sampling distribution works? Okay, so we're starting with some definitions. A parameter is a number that describes the population. All right, so the value of the parameter is not known, so we estimate it through sampling and statistics. So what this means is it's impossible to find, like let's say we're talking about heights of 10-year-old kids. It is impossible to find the average height for every 10-year-old kid in the entire world. It's just impossible. There's so many of them. You couldn't do it. So parameters are used to kind of help describe that population of 10-year-olds with an estimate. Okay, and then a statistic is a number that is computed from collecting data in a sample. Okay, so parameters describe the population the best that we can. It's not 100% accurate, but it's the best that we can based on information we gathered. A statistic is an exact computed number from data from a sample. This does not make use of any unknown parameters and is used to estimate a parameter. So for example, we can't find the height of every 10-year-old, but what we could do is we could, go to Gunderson Hospital in La Crosse and we could ask them for information on the heights of all the 10-year-olds that come to their pediatricians. Okay, which you probably get a few hundred 10-year-olds. But that would just be a statistic on just the 10-year-olds that go to Gunderson Hospital. It would not be a statistic on all the 10-year-olds in the entire world. So a parameter is describing a population through an estimate. A statistic is a number computed from a sample of people. A sample will be a smaller number of people, not the millions and millions of people in the world. All right, so for example, if a recent survey was done to see how many people currently, or how people currently feel about shopping, the survey asked a nationwide random sample of 2,500 adults if they agreed or disagreed with, I like buying new clothes, but shopping is often frustrating and time-consuming. Of the respondents, 1,650, or 66%, said they agreed. Okay, is 66% a parameter or a statistic? Okay, so since that number came from the 2,500 adults that we surveyed, it comes from a sample of people, the people we literally asked a question to and we got the answer back from them. That is called a statistic. And it's because it comes from a sample. Okay, it came from the sample of the 2,500 people that we asked the question to. In number 2, the National Center for Health Statistics reports that the mean systolic blood pressure for males 35 to 44 years of age is 128. Okay, the report says that the average or the mean systolic blood pressure for males is 35 to 44 is 128. Okay, the medical director of a large company looks at the medical records of 72 executives in the age group and finds that the mean systolic blood pressure of those executives is 126.07. So do you notice that 128 that came from the National Center for Health Statistics is different than the 126.07 that came from this large company that looked at the medical records? Okay, and just so you're aware, when you guys go out and get a job, some of your jobs and your companies you work for are going to like look into your medical health and your health records because they want healthy employees, and they want to make sure that their employees are not unhealthy people. So just a side note there. So why are they different? Well, one is a parameter and one is a statistic. So the parameter is that 128. It's because it's a statement made about males. All males 35 to 44. Okay, it's not a specific group of males, or like specific number, like 100 or 2,000 males. It's just saying that all males 35 to 44 have a systolic blood pressure of 128. Now, when we look at it within this company in the blue, that's called a statistic, the 126.07, because that comes from the 72 executives that are male that are 35 to 44. So this company looked at their males 35 to 44 years old, and they wanted to see how do they compare to what's in the green. Is our blood pressure better or worse? So they found out that their executives, those 72 people, the average systolic blood pressure was 126.07. Okay, so statistics come from a smaller sample. Parameters describe the entire population. Okay, so there's going to be a difference. Like right here, the difference is small, but the numbers are different. Okay. On the back page here, statistics versus parameters. Okay, so the mean, a statistic we're going to call X bar. Okay, because that's the mean we find out from our sample. Like if we want to find the average height of high school kids in our class, we could take the kids in our class and find the average. A parameter is what we're going to call U. That's the average height of high school kids in the world that we go with. Based on all the numbers they kind of found over the time, that's what the average of the entire population is in the world. Standard deviation for a statistic, we're going to call it S, but the standard deviation for a parameter is called sigma. So we have different symbols for the different means and standard deviations. Okay, so I'm just going to write a little side note over here to show you the difference. Let's say that they found the average age for the population lacrosse. So let's say there's 50,000, I'm rounding this, 50,000 people in lacrosse. And the average age is 45. So the average age of the population of lacrosse is 45. Now, what if you sampled 5,000 people? People, I'm going to abbreviate, from lacrosse. And the average age was 39. Okay. That shouldn't be a surprise because the age of the entire population is going to be different than the age of a sample. Right? Like the average age of all the kids in Logan High School will be different than the average age of all the kids in our classroom, because our sample is smaller than the entire school. So there will be a little difference there. Okay? So just so you're aware, X bar So X bar is the statistic calculated from the sample that estimates the mean of a population, which is U. So by taking numerous samples and finding their mean, we develop an estimated mean for the population. So like we said, U is the mean of the sampling distribution. So it'll be like if we're talking about age, of high school kids. You can find the average age of high school kids from Logan, and then the average age of high school kids from West Salem, and then the average age of high school kids from Stevens Point. And if you find all these averages, those averages, when you put them together, are going to estimate the average for the entire state or the entire country. And then S is the statistic calculated from a sample that estimates the standard deviation of the population. Okay, but if we do enough samples, we create a sampling distribution that is the ideal pattern for our population. And sampling distribution is a distribution of values taken by the statistic in all possible samples of the same size and from the same population. Okay. The ideal pattern that would emerge. So basically what this means is if you want to find the average height for a high school student, okay, we'll use height because height's kind of simple. If you took, there's a sample of 20 high schoolers and then someone else and found the average height, then somebody else did 20 high schoolers and found the average height. And then let's say over in Milwaukee, they took 20 high schoolers, found the average height. And then up north in Tomahawk or Green Bay, they took 20 high schoolers and then 20 more high schoolers and 20 more high schoolers. And if all these people found the average height for the 20 high schoolers in their sample, and then you average out each of the averages, it will give you an estimate for the mean population. Okay, in this discussion part, that link, you can copy and paste it or click on it. I'm going to go through this with you in class, or I might make a separate video on it, but we're going to skip past this right now, and we will come back to it in class. So we'll go on to the example. So sampling distribution of a sample mean. So what we have is we're going to draw a simple random sample of size n from the population that has a normal distribution with mean u and a standard deviation of sigma. So up here, I'm going to put some letters for you. N is sample size. That's just how many people are in your study or in your sample. Could be 10, could be 20, could be 12, could be 50, could be 100. U is the mean of population. X bar is the mean of the sample. Just like we talked about earlier, the mean blood pressure or was it mean cholesterol from before was 128, I believe, but in the sample of 72 executives, it was 126. So these can be two different numbers. Many times they are different numbers. And then sigma is the standard deviation of the population. Okay, so those are the numbers we'll need to know. Sigma, U, X bar, and N. All right, the sample mean, like we said, is X bar, has the normal distribution. So we'll write it like this, N, and then it's going to be U, comma, and then sigma divided by square root of N. So if you want to find the normal distribution, we would use U, which is the mean of the population, and then for the standard deviation, we're going to use sigma divided by square root of n. Okay, and then just keep in mind that u x bar is the same as u. Okay, and then the standard deviation, x bar or sigma x bar, is going to be sigma divided by square root of n. Okay, and this might not make a lot of sense right now, but as we go on, it's going to, when we get to some examples, hopefully it kind of clears some things up. So in example 3, the height of young women varies approximately according to a normal distribution with a mean of 64.5 and a standard deviation of 2.5. Okay, this was what the distribution would look like if we were choosing a single woman randomly. Okay, if we choose a sample of 10 women, what will the mean and height standard deviation be for the sampling distribution? So what we have is n. Oops, let me change this. N is the number of people in our sample, which is 10. Okay, say in the sample of 10 women. Okay, U is the average of the population, which is 64.5. So if we just went out there and found and grabbed a person, grabbed a woman, the average height, if we just went out and did that, would be 64.5. Okay, and the standard deviation for the population would be 2.5. Okay, so what we want to find is what would the mean height, the average height, and the standard deviation be for a sampling distribution. So we're saying, like, what would the average height be if you did a bunch of groups of 10? Okay, and what would the standard deviation be if you did a bunch of groups of 10 people? So U of x bar is going to be the same as U, so 64.5. So the average will not change. But the standard deviation is going to be equal to sigma divided by the square root of n, so divided by the square root of 10. So it's going to be 0.79. Okay, so the standard deviation, if we went by groups of 10, would be smaller. It would be 0.79, where the standard deviation just for the entire population is 2.5. Again, what this means is instead of just taking one person, one woman at a time, and then finding the average and the standard deviation, what we're going to do is take a group of 10, find the average, and then do another group of 10 and find the average, and another group of 10 and find the average. And if we do that, it's going to be less spread out. So that means the standard deviation is going to be smaller. Okay, and then number 4, a national assessment test is used to measure the quantitative skills of young Americans of working age. Scores in the test range from 0 to 500. A person scoring higher on the test has more basic mathematical ability than someone scoring lower. The mean score of all exam takers is 272, and the standard deviation for all exam takers is 60. They're saying a sample of 840 men was taken. What is the mean and standard deviation of this sampling distribution? So we know that the average was 272. This is for the population. The standard deviation for the population is 60. And then we know that n is the size of our sample, which was 840. Okay, so we want to find out what is the mean for this. The mean of our sampling distribution is still 272. That does not change. Okay, but the standard deviation is going to change. For the standard deviation, you take the standard deviation of the population divided by the square root of n, which is the number of people in your sample. So in this case, it's going to be 2.07. So the standard deviation in this sampling distribution is 2.07 compared to the standard deviation in the entire population, which is 60. Okay. And we're gonna explain more of this when we get to class. We'll watch that link in the video and try to clear this up a little bit.